Thank you very much for being here. I'm the last person between you and a nice happy hour, but I hope that you will bear with me for this last presentation. I'm very excited to be particularly here because it was about 2 years ago that I came to my first annual meeting here, and being at BITS basically exposed me to a whole range of tools and language that I could use to focus and narrow down my research better, particularly to what I'm going to be sharing with you today is about my dissertation. So one question that I wanted to use for you to motivate you a little bit is, although most of you are researchers, you produce knowledge, and I wanted to think for a second, how do you think that research is used for policy? Just what do you think the mechanisms are? Daniel yesterday suggested that p-values should not be a criteria to get in the New York Times, but implicitly you were thinking of a mechanism that research affects policy through the New York Times, which is a valid mechanism. I'm going to share with you a different mechanism, a different link. The one that I'm particularly interested in is that researchers produce knowledge. It's a general purpose knowledge, but then policy analysts at places like the Congressional Budget Office, Secretary of Treasury, Ministry of Finance, basically apply this general knowledge to answer a specific question. They do empirical analysis to quantify the gains and losses of a specific policy to inform a specific set of clients. And this is an ideal setting where basically all policymakers start from the same set of facts, and then they can make different decisions. They can support or oppose different sets of policies. But this is an ideal setting in the sense that there's one source of research, one policy analysis, and we learn about the normative preferences of policymakers. That's a little bit of the situation nowadays, in the sense that facts tend to be fungible, flexible. This is from the New Yorker. And the idea, I tie it back, my interest on the issues on policy analysis, they relate to the issues that basically you are tackling in research. There's a multiplicity of research with different degrees of credibility, and it's hard to identify what's good research and what's not so good research without having everything open. So the idea is, let's open up policy analysis. Right now, BITS, Center for Open Science, and other places are pushing towards opening up and identifying what good research is. Let's apply this similar ideas and what can we learn in the world of policy analysis. So as a starting point, or the definition for the problem, I take basically the work from Charles Manski, that he has identified that policy analysis in general has low credibility. In formal terms, the policy estimates that are produced, they can be anywhere, and his prescriptions are, first of all, let's show a little bit of standard errors. Second, let's follow a little bit of what Carlos was saying and bound a little bit the estimates. And third, show some decision criteria associated with this. And as a complement to that, basically what I proposed in my dissertation was, okay, why don't we bring a little bit of the lessons from open science into the world of policy analysis? Let's incorporate guidelines and tools that are being promoted in open science, and to fix ideas and to demonstrate all these somewhat abstract concepts, let's apply all these things in a particular case study. So why is this a problem? I sort of gone through it a little bit in explaining that we don't want policymakers to be able to cherry pick facts. That's undesirable, but it's also undesirable to do an analysis, to do a cost-benefit analysis, a microsimulation, whatever, and 5 years after, a year after, there's some recurrence in this that you have to estimate the same parameters again, produce the same report, and all of a sudden the analyst who did that the last year, it's gone, they don't remember what they did, nobody can read the code, nobody can read the spreadsheets, and so on. So the losses in automation, they're quite big. And also, there's also a unrealized gain in the sense that if we open up the whole hood, we can understand how each marginal piece of research can teach us more about what are the effects of new knowledge. So at a big level, what I did for my dissertation was just draw a comparison between the credibility crisis in science and policy analysis, adapt the guidelines and tools to the setting, and what I'm going to be focusing today to just fix the ideas is how do this apply in a concrete setting. A general comparison is that there are similar problems, there are some differences, but the key issue that I want to focus today is that the common solutions for both empirical analysis are the idea of disclosure of key details and open data and materials. And there are some key tools that policy analysis can benefit from, particularly the use of dynamic documentation and version control. Another important point is that in the space of research, it's well defined who should be thinking about this, research funders and journals. I want to emphasize that, particularly as I'm going to be referring to the case of the Congressional Budget Office, that's going to be my case study. It's not clear who should be thinking about this in policy analysis, because policy analysis they need to deliver a report in the next 3 weeks, 3 hours, or in a very short period, and it's an additional burden to ask them to start thinking about making their work reproducible. But the good thing is that at BITS we're starting to think about this now. The overall message that I wanted to take away with the previous table that it had a lot of stuff in it, but the idea is that we don't know how are we doing analysis, both in science and in policy. So basically, let's open up. Let's open up the kitchen, show everything. And that's pretty much what I'm going to attempt to do and exemplifying in a specific case study. Not because I'm particularly focused on the minimum wage, but it's a good example to relate to other types of policy reports. So basically what I took was a report from the Congressional Budget Office that was carried out in 2014 to estimate a potential increase in the federal minimum wage. And they estimated 3 key effects. One, that about 500,000 jobs would be lost, that about 17 million people would see an increase in salary, and there would be somewhat progressive distributional effects. So these were kind of like the key policy estimates, and this was the key input from research. What I'm going to show you today is just how I adapted the guidelines from open science and how those guidelines apply and how I reproduce the CBO report using dynamic documents and version control. So for the guidelines, what I have in mind is this is the bare bones of any policy analysis, in the sense that you use some type of data, you use hopefully some type of research as an input, and unlike research, you do need to provide a final answer, so you cannot say more research is needed. So sometimes the models do not close up, and you need to plug in a number in there. So that's guesswork, and that's very common, and there's nothing wrong about it. The only issue is that it's not clearly explicited. We use models, and then we produce policy estimates. And the idea is a good guideline would allow us to identify all of these components and identify and see all the connections, and also a good reproducible model would allow us to understand if we change or if knowledge increases in some dimension here, how does that affect the final policy estimates? This was my adaptation of the Transparency and Openness Promotion guidelines. It was a very subjective adaptation from what TOP has written in terms of transparency and reproducibility. For the context of policy, the main idea I wanted to take away is not so much the version of the guidelines, it's the idea that there are different levels. It's not a 0-1 problem, there are different dimensions, and there are it's an evolving document. It has a large number of authors. It has a large number of contributors. So it's a learning process that's basically what I want to bring to the discussion of policy reports. When I applied these guidelines or this rubric to the CBO report, basically CBO, those three estimates that I show you have a somewhat comprehensive report that explains what they did. There is a rationale, there is a model, they cite some of the data that they use. Some of the things have to be inferred or guessed, but I use particularly CBO for precisely because I think that they're in the frontier of being transparent among policy analysts. And in some cases, you just see a policy report is just a number that it's cited somewhere and it goes into the law or something like that. But there's still space for improvement in the sense that it's not strictly all the details are not there. There's the data is not there. The code is not there, and it's very far away from the ideal of a one-click reproducible workflow. So what do I mean by ideal? Let me show you just a quick demonstration of basically what I did as an example of how should we think of transparent and reproducible policy reports. Basically, this is in essence the same report, benefiting from hindsight on where the discussion was. But the difference is that instead of a PDF report that has just some narrative explanation of what happened, what you have here, it is the narrative component, but when you go to the analysis, for example, you discuss in detail the data that is used. And CBO makes a reference that they use the current population survey, but there are 3 different versions around of the current population survey for each round, and it's not clear exactly which one they use, which weights did they use, and all those components are not clear. So here I make very clear which version am I using, which weights am I using, but also the code is in the document. So that's part of that. It's an essential part of dynamic documents where you integrate the narrative with the code all in one file, such that you don't have to believe me up here. You can just go and see exactly what I did, which is, it probably has many mistakes, and the idea is for other people to identify those mistakes in the next discussion of the minimum wage that for sure is going to happen between 3, 5, or 10 years. We do it a little bit better. And it's pretty much all along the lines in the sense that following the spirit of dynamic documents that some of you might be familiar, is the idea that there's a minimal amount of hard-coded numbers here. There's no copy-pasting. There's all of the analysis is inside of the document. So this visualization that displays the distribution of the working population in the US, it's not copy-pasted. It's produced every time that you run this analysis. And pretty much this opens up the discussion far more than what has been talked till now. When this report came out, 90% of the discussion was around this parameter over here. And it is a relevant parameter. It's important. There's an important academic discussion around this. But there's some really interesting, at the same time, strange parameters in the calculations that they're not that relevant for research, but are extremely consequential for the results that we see at the end. And the version control part of this is, of course, that you can, all these dynamic documents is just our markdown file that is in a GitHub repository, and you just grab there and rerun the whole analysis. That's the idea. One final dimension that has to do with transparency, it's that got me thinking at the end of my work. It has to do with transparency. Well, first of all, there's transparency. With a fully transparent and reproducible workflow, we can fill in this diagram for each type of analysis. But one thing that got me thinking particularly was the output area, in that it's very important, particularly when we produce policy reports, that it's very clear what information do we want to share with policy makers? Because even if you produce one report and you produce, it's not so clear what the true estimates are. For motivated reasoning and for the same reasons that apply for research, policymakers are going to go through the report, and if they're in favor of a policy, they're going to look for salient positive elements, and if they're against a reform, they're going to look for salient negative elements. So the idea is, instead of putting out all these 3 estimates that I showed you at the beginning, let's try to bring everything together in just one visualization, assuming that policymakers are very time constrained and they're not going to read the report, they're just going to look at one graph, but let's reach consensus on what that graph is going to be or what the table is going to be. Even reach consensus before doing the analysis. So this was sort of like my first attempt, in the sense that there were wage gains, there were people who were losing their jobs, and there were some distributional effects. So the wage gains are the black dots here, and this is the people are sorted according to their income per capita. The black dots are people below the 0 line, and this seems clear. As we mentioned before, there's more people who are gaining than people from losing, but it's important to put the gains and the losses up there so people can explicitly weigh those. And also, this reflects this other important line of people who's paying for the raise in the minimum wage. That's given that there's not, remember that guesswork component that I told you? Given that there's not much information of how is actually the minimum wage paid for, CBO had to assume that 1% of the people below one poverty line pay people below one poverty line pay 1% of the increase, people between one poverty line and 6 pay about 29% of the increase, and people above 6 poverty lines paid about 70% of the increase. That is not grounded in any literature, because there is no literature about that. But you need to make those type of assumptions. The important thing is that we want all this thing to be in one place, but it wasn't there yet, because these black dots were effective losses and effective gains, and the blue dots were average gains and average losses. So I put everything in average by poverty line beans. So this gets closer to that one visualization that we should aspire for. But the problem is that within poverty line beans, you don't have the same amount of people, so you are weighing each group differently. And this is kind of what the final visualization that I propose is the starting point that policymakers should read. And it's not that this should be the be-end all and definitive version, but it should. Whoever thinks of a better one should make it very clear of why, and why should we account for other components. In the same way that we improve the model, we can improve the way we report the results. And one important benefit of this framework is that when you have all the kitchen open, and when you have a fully reproducible report, you can do extensive sensitivity analysis, and you can, as I said in the beginning, you can learn a little bit about where would the marginal piece of research help the most. So remember that there was a large discussion about, I told you that there was a large discussion about the elasticity of labor demand for teenagers or in fast food restaurants. This was made with, these are the estimates, close to the estimates of CBO, using their estimate, which was of one school. This is if you choose of another school. So the losses, people who lose their wage, it's reduced somewhat substantially, but overall the picture doesn't change so much, particularly relative to the other variations. For example, if you move, remember that we talk about the distribution of losses. What happens if you choose, instead of choosing that arbitrary distribution of loss, you choose something that is also as arbitrary, but less progressive in some sense. The change is much more substantial, and if you basically assume some type of welfare function, some type of a hypothetical policymaker that it's aggregating all these gains and losses, and is weighing them in some sense. And I change a little bit all the parameters in the model, just increasing them 10% or reducing them 10% for two hypothetical policymakers, one that likes and one that dislikes policy, the one that likes and one that dislikes redistribution. You get that there are multiple components in the policy analysis. This is the one that takes all the debate, the elasticity of teenagers or in fast food restaurants. It's somewhat similar in variation on the effects of, for example, learning more about the wage growth, but there are even more components in research. For example, the ripple effects. How much does it change how affected are people who are on the border of the increases on the minimum wage? And we know much less about that. And among the guesswork, who again, it's completely fine that we have all these components, but it's better to make them explicit. The variations are somewhat similar to the ones that takes all the discussion, especially if you start exploring more about who pays for the raise in the minimum wage. So what you take away from this table is there are components that are worth studying, but there are other components that are as worth studying but are somewhat unexplored. I wanna just to take the final 4 or 3 minutes to just as a way of summarizing. It's that let's assume that this type of reports, fully transparent and reproducible reports, become the new status quo. What will be the consequences of this? Remember that these are reports that are recurrent. So the next time that we write a similar report for the same country, or that we write, or when we write a similar report for a different country, the costs are going to be much smaller because basically we're doing the same thing. More important, each new report is going to be incremental. It's going to be incremental in knowledge from what was done before. So it's not going to happen that you literally reinvent the wheel every time that you do any of this analysis. A very exciting part from the perspective of analysis, of research, is that most of these reports take similar inputs. They are kind of like canonical starting inputs, kind of like the value of a statistical life, the associated death weight losses with taxes, and things like that, that when we learn something new about these parameters, it should automatically change how we quantify many policy reports, many policy analysis. And also, as important, it should get rid of this problem of report wars when you have different advocates and opponents coming out with their own version of what the facts are, and it should provide a much easier ground to have a substantive conversation and separate the normative from the policy, from the positive components. And this is just a toy example that it's not based on the analysis from CBO, but it's just to fix a little bit of the ideas that people can disagree even in what the final estimate is, but they should be able to say, okay, this is my report, here are my equations, and here are the parameters of the equations, and if I change my assumptions, I immediately see how the estimates change, and then I can come to the table with what my version of the report is instead of coming with parallel realities. Just as a final thing, I wanted to mention what the next steps are. The most important thing that I wanted to get your ideas from is that the exercise I did with CBO was more a single person exercise without buy-in from the organization, and now we're trying to implement these ideas to a similar policy report, but in collaboration with the organization, in the sense that we can observe more and learn better of what are the benefits and costs of this. So if by any chance you are among this world of policy reports producer, and you think that your analysis is worth identifying as the wheat from the chaff, you think you're something like there, basically contact us and we can work together to bring the ideas from open science to policy analysis. Thank you. Questions or?
So a few slides back where you showed the sliders and all the that changed the various assumptions. I'm curious how you identify which policy parameters are the uncertain ones, like which ones do you include here and which ones do you, because presumably there's more than 5 parameters in the report, right? Because this is something, so I teach cost benefit analysis to master students, and it's always hard. They say, you know, what should we do sensitivity analysis for? Right? What is uncertainty? And so, do you have any guidelines for how to?
So, basically, the way I would think of is that pretty much when you do those type of cost-benefit analysis, and you move around kind of like 1 or 2 parameters or several parameters, but it's kind of like a one-off exercise. So it doesn't allow you so much to play with multiple at the same time. And basically, this type of tool would be to identify, I don't know, the 10 most debated. But this is important. This is just kind of like the last part of the report. The most important component for my taste would be the full dynamic document, such that you identify all the components, and then people can just go there and redo the whole thing. And I didn't emphasize much, but the whole point is that that dynamic component document should be one-click reproducible. So it should be relatively costless to change things.